What's up, math gurus? My name is Nikita, and I'm from the Gavilan Writing Center, where you could reserve in-person tutoring appointments. You could also reserve online appointments or check through these online resources on the Gavilan Writing Center YouTube channel. Today's topic will be about the limit formulas for differentiation and also some extra special trigonometric differentiations. So, starting out, what was the word of the day in the last video? Instantaneous. Because why? Because derivatives are the instantaneous rate of change. So starting out with limit formulas, the instantaneous rate of change between 2 points, two really close points, with the distance between them approaching 0, in other words, being really tiny, can be represented by the limit formula, lim, as h goes to 0 of f of x plus h minus f of x over x plus h minus x. To basically regurgitate what this represents, the f of x is just the point x, and the f of x plus h is the point that is h away from x. The denominator can be simplified to be just h, but this is what it looks like. This is the most important limit formula in calculus, and by fully understanding it, you understand the concept of derivatives. So, let me use my telekinesis powers on you to figure out exactly what you're thinking. You want to use the limit formula to solve more long problems. Great! Here's the example from last time. So you're given the function of x cubed minus 3x minus 2. And what is the equation of the line tangent to the point x equals 2? So, the limit as h goes to 0 of f of x plus h. Now remember, the plus h has to get added to each x. Now I did not understand this when I was first getting started, and it really bit me, so I don't want you to make the same mistake. So you have to add it to each x. So you have this x right here. So you do x plus h, and you cube it all together. Then you do minus 3. Again, don't forget the h. The h is always paired with the x. They like each other. 3x plus h, then minus 2. And we could put parentheses around all this to make it easier. Or brackets. Then we have just f of x, so no h's are necessary here. So we have x cubed minus 3x minus 2. And this is all divided by x plus h minus x. In other words, it is all divided by h. Right? So, although this is pretty tedious, you do have to evaluate this factored form. So, if you want to learn more about factoring, you can watch my previous video. If you already watched it, you should know a lot by now. So, but I only went to squares. I didn't talk about cubes. But the general formula is that you grab the first term, which is x, right? And you cube it. Then you grab 3 times the second term, h, times the first term squared. Then you do 3 times the first term times the second term squared. So here, the first term would be x squared and then plus h. So we have x squared and h. And then we have h squared and then plus x. Then lastly, we just have h cubed. And how I like to think of it is it goes from x cubed to x squared to just x to x disappearing. And kind of in the opposite order, we have no h, then h to the first, then h to the second, and then h to the cubed, right? So let me remove all these lines. 3h squared x plus h cubed. And then we have to expand the negative 3 times x plus h. Then subtract all that by x cubed minus 3x minus 2. So once you do this, you might see that, okay, we have a negative x cubed here and an x cubed here. So what do? You cancel these out. Now remember, this negative distributes among inside the parentheses. So we have a positive 3x and we have a negative 3x here. So what happens? These cancel out. Then again, we have a positive 2 and a negative 2 right here. So they can cancel out. And once you're done with this, you're pretty much left with 3h x squared plus 3h squared x plus h cubed minus 3h. And you can't forget about that denominator and, of course, that limit as h goes to 0. Limit as h goes to 0. And all of this is divided by h. Now, what do you guys see here? What can you do? Well, what I personally see is that we can divide h among all the factors or all the variables. So that will give us 3x squared plus, can't forget the limit function. That'll give us 3x squared plus 3hx plus h to the second minus 3. And since we divided by h, this all over 1, or just over nothing. Now, the lim states that h goes to 0, and it goes infinitely to 0. So we could substitute h equals 0. And since anything times 0 is 0, what we're left with is just 3x squared minus 3. And you might be asking, okay, well, why couldn't I just substitute 0 for h since the very beginning? Well, you see here, h is on the denominator. And if we substitute for h, we divide by 0, which we can never do in the math world. So that's why we have to do this tedious work of expanding all these equations, then subtracting them, then distributing or dividing the entire numerator by the denominator h. And you're left with a couple variables where you could input h equals 0 to get, here, 3x squared, and then minus 3. Now, wait a minute. Where have I seen this before? Oh, wait. 3x squared minus 3 is our differentiated version of x cubed minus 3x minus 2. Isn't that crazy, you guys? You move the 3 here, subtract 1, and you're left with 3x squared minus 3. Moving on, though, if we just use our same process as last time and we plug in x equals 2, then 9 comes out, which is the slope. And by following the point slope formula, like we did last time, we get our equation y equals 9 of x minus 2 plus 0. Now, I want you to pay attention because this is a very important part of calculus. This entire part, the limit formula, this is a very important part of calculus. And if you can understand this, it'll make your math journey so much more easier. Moving on to some other differentiation formulas you might need to know and remember any calculus journey, the derivative of sine is cosine. And the derivative of cosine is negative sine. The derivative of negative sine is negative cosine, because the derivative of sine is cosine, and then the negative just carries over. Then the derivative of negative cosine will just be sine. And let me think. Where have I seen? Oh, there! I've seen it here. So, as you can see, the two loop together. And yeah, you just know that the derivative of sine is cosine and cosine is negative sine, and you'll be able to differentiate them pretty easily. Now, let's look at tangent. So, the derivative of tangent is secant squared. Sadly, tangent does not loop like sine and cosine does, but it's something you're gonna have to remember or memorize, but it's something that you might be able to put on a cheat sheet. Something like this, I feel like you don't really necessarily need to know, but if you want a more in-depth explanation of why these trigonometric identities, or why the derivative of secant is tangent secant, or why the derivative of tangent is secant squared, if you guys want a video about that, leave a comment and tell me, and I could make you one where I basically just go over all of these formulas and prove them. But moving on, the derivative of, the derivative of cotangent will be negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. So, as you might have already noticed, if you memorize tangent, the derivative of tangent, the derivative of secant, you pretty much know the derivatives of cotangent and cosecant. Because as long as you remember the co-functions, you could use a little trick, I guess. It's the key to remembering these is that the co-functions, are just like an add-on to the regular functions. So the derivative of these co-functions are just negative co of the normal functions. So like tangent, the derivative would be secant squared, but the derivative of cotangent would be negative cosecant squared. Same as how the derivative of secant is tangent secant, whereas the derivative of cosecant would be negative cosecant cotangent. So I just thought that was a pretty cool way of memorizing these things. But again, if you want a more in-depth explanation of why the derivatives of these trigonometric functions are so, then leave little comments down below, and I'll make sure to read them so that I know to prove the formulas. Now, knowing more about these limit formulas, you guys can officially tell on your siblings or cousins for touching you, even if they weren't, because in calculus, when a distance to a point, or your face, can be smaller than whatever number you can think of, it counts as being at that point. So have fun with that information. Otherwise, I hope you enjoyed the video, and I'll see you next time. Goodbye.